Hi, this is Satyakripa, a vibrant design thinker from DTSCD Placement Department. Today, let's discuss on the topic complex number and its significance in mathematics. Come, let's get into the video.
Complex numbers and its significance in mathematics. First, let's explore how complex number came into existence. Discovery of complex numbers. Imagine yourself in the mathematical landscape of the 16th century. The quest to solve cubic equations led Italian mathematicians to ponder seemingly unsolvable problems. In 50 AD, Heron of Alexandria was the first person to come up with the idea of using complex numbers. He was trying to find the volume of section of a pyramid that involved the slant height of the pyramid. Certain values of the slant height produced the square root of a negative number, and he was not clear with these results. Soon he gave up. In search for solutions, mathematicians like Girolamo Cardano dared to consider what were then deemed impossible roots, involving the square root of negative numbers. Then, Girolamo Cardano, an Italian mathematician who was interested in solving cubic and quadratic equations, gave solution as imaginary numbers, and then he gave up too. Later, many mathematicians worked on it. And finally, William Rowan Hamilton advanced the idea that complex numbers can be represented as a pair of real numbers. Fast forward to the 18th century when Euler boldly introduced the concept of imaginary unit, denoted as I, laying the foundation for the complex number. Now, Euler introduced the notation I as a solution for the equations. This discovery transformed mathematics, providing solutions to equations that eluded the confines of real numbers. The elegance of complex numbers unfolded, revealing connections with trigonometry through Euler's formula and finding applications across various scientific domains. The journey from skepticism to acceptance marked the discovery of complex numbers, showcasing the beauty of mathematical innovation. These numbers, born from the pursuit of solutions, now stand as fundamental pillars in the vast landscape of mathematical exploration. In mathematics, we often encounter situations where equations have no real solutions. Enter complex numbers. Now, you might wonder, why do we need these complex numbers? Well, they open up new possibilities, providing solutions to equations that couldn't be solved with real numbers alone. A complex number is a number that can be expressed in the form of a plus ib, where a and b are real numbers. For example, a is called real part denoted by re, and b is called imaginary part denoted by im, that is az. Is it equal to 3 plus 4i? Here, Re, real number, is equal to 3 and imaginary number is equal to 4. 2 plus I. Here, real number is equal to 2 and imaginary number is equal to 1. One fascinating connection is Euler's formula. E to the power of ix is equal to cos x plus I sin x. This formula elegantly links complex numbers with trigonometry, unleashing a powerful tool for mathematical analysis. So, the next time you encounter a challenging mathematical problem, don't be surprised if complex numbers come to the rescue. Bring a new dimension to the solution. Thanks for tuning in and happy exploring in the world of mathematics. Before we get further into this conversation, there is a question. Have you heard of the word fractals? It is a complex geometric shape that exhibits intricate pattern at every scale. They are born from their iterative application of mathematical formulas. Consider how tree branches. Each tiny branch repeats the shape of the bigger limb. resulting in a self-similar pattern suggestive to fractal geometry. The jagged contour of the coastline, outwardly chaotic yet amazingly orderly, is the reminiscent of the self-replicating nature of fractals. So, whether you're exploring the depth of complex numbers or marveling at the beauty of fractals, you're delving into the wonders of mathematical universe that combines imagination and precision. Now, application of complex numbers. A number system that go beyond the realm of real numbers enters complex number, the perfect blend of real and imaginary numbers. First, vibrant world of electrical engineering. Engineers, brace yourself. Complex numbers are your secret weapon in dealing with alternating currents, impedance, and signal processing. Complex numbers are fundamental in electrical engineering, especially in AC circuit analysis. A crucial notion in this domain. The real part represents resistance, whereas the imaginary part represents reactance. This method simplifies computations and allows engineers to efficiently evaluate complex circuits. Next, quantum leap in physics. Quantum mechanics enthusiasts rejoice. Complex numbers play a crucial role in representing quantum states and operators and locking the mysteries of subatomic world. Complex numbers are used to define wave functions in quantum mechanics. The imaginary I is inherent in Schrödinger equation, a basic equation in quantum physics. Quantum mechanics uses complex numbers to predict and understand particle behavior at quantum level. Dynamic solutions in control system. Control freaks, take a note. Complex numbers are your go-to tool for analyzing and designing dynamic systems, ensuring stability and optimal performance. Mathematicians behold the beauty of complex analysis. From intricate functions to elegant theorems, complex number add a touch to aesthetic harmony to the world of mathematics. Beyond the theoretical realm, complex number find their way into everyday application. From image processing to fluid dynamics, revolutionizing the way we perceive and interact with the world. So, concluding, whether you are an engineer, physicist, mathematician, or someone with curious mind, embrace the power of complex numbers. This application is your gateway to understanding and mastering this extraordinary mathematical domain. Thank you for watching the video.